Hello and welcome back to the channel. And as per latest questionnaire, I prepared a tutorial for top-down 2D shooter. It's a cool little game where you shoot zombies and go around the level. You have health and you have ammo that you can manage by picking up health and ammo pickups. And the aim of the game is to find a key and extract with it. So let's see how it looks. Let's start by setting up our project. I'm gonna open Godot and I will be using a 4.1 stable version, but as you can see here, but I also tested it with 4.2 dev release. There is one slight problem with tilemap in 4.1, which may make us force us to update the version that we are using, but I hope we can overcome that. Let's create new project, find a place for it, and let's create new folder. Okay, we will be using standard forward renderer Git, but it doesn't really matter when it comes to renderer. Okay, as you can see, I simplified my editor a little bit, so it only displays 2D and script, and no 3D, and this can be done by going to Manage Editor Features, and I switched the profile. I created new profile, 2D, and I disabled 3D editor, and then basically I went down and I disabled some 3D nodes here, like Word 3D and other stuff. So everything we were working on is simplified, but if you would like to bring it back, you can just reset to default, right? And now you have everything here. I'm using my 2D make current to simplify everything when it comes to 2D development. But you can create your own profile if you'd like. I will start by bringing in all the assets that we need, and we'll discuss them briefly. Let's drag and drop this. Okay, so what we have here in the assets are sprite sheets for the characters. And if you don't know, I went to KNNL, which is wonderful source of assets, went to 2D, and then I found shooter, and I used top-down shooter as a reference and as a source of assets. Other assets, some of them are mine, most of them are from KNNL. Those health pickups, for example, and bullet icons are done by me, which you can tell because, well, I'm not a 2D artist. And these are some free sounds from the internet that I found to be matching our game style. So that's basically it when it comes to setup. We have our assets and we have editor setup. So in the next part, we'll start working on the tile set. In Godot 4.1, there's actually a very big bug that basically makes your editor freeze when you're working with tileset. So what you have to do is go to Godot, find, and here we have to find downloads, and what we need is see the latest preview builds, and we're looking for that one, or at least that version, Godot 4.2 Dev 5, because it has the fix for that issue with tile sets. So let's click Windows. It's gonna download Dev 5 version, and then just unzip it and run it, as I'm going to do. So 4.2, and we started the tutorial with the 4.1 version, so it's going to say that the version isn't matching, but still we can run it. So open anyway. Let's remove that. Okay, and now we can start working on our tutorial. Oh, let's also get rid of that. So this is basically where we left off in the previous tutorial. So what we're going to do is first we're going to create a main scene. This is what I typically do. And then I place all of the elements of our game under the main scene. Let's save scene as, and let's create a folder called scenes and save main scene. Okay. So we're pretty much set to start working on our tile map, because tile map is going to be our main node for the level. Let's add that, and then to start working with it we need a tile set, and as you can see we have two new windows in the editor, tile map and tile set, that we can use. And let's start by actually creating a tile set. So in the assets, you can find sprite sheet tiles, and you can drag and drop those into tiles window. That's gonna automatically create a tile. The problem is that the configuration of the tile isn't really correct, right? As you can see, the cells in the tile set, the graphics asset, have different separation and different size than what we have configured right now. So let's fix this. Start by clicking on the tile set in the inspector so that it unfolds, and change the tile size to 64 by 64. And then going into tile set window, we need to properly configure our tile set itself. So we need to change the separation to 10 by 10. And then we need to change the texture region to 64 by 64. And now our tiles match perfectly with what we have here. And basically, if we go to tile map and click on one tile, we can start painting our tile set. Okay. But before we'll start with that, we will need some terrain sets and some layers. So let's define the layers that we will be working with here. And this is going to be background, foreground, decoration, and I call this on decoration. So if something is like on the table, where the table is a part of decoration layer, it's gonna be something like that. Okay, perfect. And with that set, we can start drawing. So first thing that I would like to do is to create the environment on which we'll be moving. So what we can do is we can create a terrain set. So here we go, and we can add a terrain. And that's gonna be grass, and choose a color, set it to something greenish. Okay, and then here in terrains, we can add this very simply by going to tile set, select, and we can add it to terrain set, which should be here, terrain set 0, grass. And we can just click on all of these, and now it's added in Paint to terrain grass. And then in tilemap we can go to terrain, grass, and we should be able to, oh, let's first paint this. Okay, then going to tilemap, we have our terrain set to a grass, and then we can just go to our tilemap and drag to create where our game will be, right? So basically in this area we'll play our game. We can add a little bit here. You will see me adjusting that as we go. So this is our grass and this is our background. So now I think it's good time to place some walls, right? So let's go to tile set, and basically I will speed up this part of the tutorial. What I will be doing is I will be selecting tiles that I need to create a set of buildings, of rooms for our gameplay. I will be working with that orange kind of walls. Oh, and yeah, make sure to choose the proper tiles. Okay, so this is the plan of the first building, and if you erase some tiles, you can just go to terrain, grass, and just add the grass, but we will not be having grass inside of the building. We'll actually place floors here. So let's maybe create another building. Okay, so this is going to be the layout of the second building, and you can mix and match as you need. And maybe just like one more, maybe very long building right here. Okay, so we have outline of our buildings. Then now would be a good time to add our floors. So to do that, we can go to terrain sets, add element, and I'm gonna call this floor 1. I can go to tile set. I can go to paint. I'm gonna select terrain set 0, floor number 1, and this is going to be this one. Let's just paint this. Perfect. And now if I would like to place that, I can just go to tile map, terrains. Let's see. Why isn't this visible yet? Oh, now it's here. Okay. And for example, I would like to give that floor to this room. Oh, I can press this, drag and drop, and now we have randomly placed tiles of that floor. We add this here. Let's add another floor, floor 2. Change the paint to floor 2 in the tile set. Select everything. And now let's just paint real quick. Perfect. And since we are here, we can add the floor 3. Right. And select floor 3. Select the tiles. Paint it. Okay, cool. Then back to tile map, we can start adding these where we need them. So now easily we can specify which floor should be in which room. Cool, perfect. And we can add them everywhere. Maybe here we can add those two. These are like the entrances, oops, entrances to the building. Oops, wrong color. No, it's still wrong, sorry. should be free. Okay, and then the last building here. Okay, so this is how we basically planned our game area. Of course, not done, as what we will need to do is add more layers to it with the decorations and stuff like that. But that's basically it. We'll be playing around this green area and in this free buildings, and I believe this is a good place to stop that episode. I mean section. In this section, we'll try to bring a little bit of life into our level by adding some decorations. So first things first, let's switch the layer here to decoration, and let's start thinking what can we add here to make it more fun. And you can see there are some boxes here. We could place some columns here and there. So maybe let's start by placing a few columns. Okay, then we can add some boxes. And maybe a few plants here and there. Okay, and then let's actually try and bring it to life by maybe creating a kitchen. So maybe let's say, let's move this, grab this and move this down, and let's place a kitchen table here, I mean kitchen sink. So let's change the drawing. So we're gonna have that, and then that, and this. I don't know what it is, but it looks good. We can also add a sofa here, and I would like to place the sofa here, but I would like it to face down instead of up. So what you can do is go to tile set, find those tiles that create a sofa, and click, let's do select and create alternative tile, and it should pop right here. Let's do that for all of them. Okay, now we can modify this by clicking on it and saying, where is it, flip V. Okay, and now we can go back to time map and use this, maybe not here, but here, to create a sofa. And then on top of that, we can place a table. For example, here. Okay, so then going here, we can make it like into a small dining room. So for example, we could do that and that and place that, and we can add, oops, add this, and to place it also here, but turn to the other side, I'm going to go to tile set. create alternative tile, flip V and transpose, and then I can place it here and here, and also let me grab the blue one. So create alternative tile, go to tile map, sorry, go to tile set, and not flip V. And that's how I will be working basically room by room. So I will speed up video right now to, well, create something that resembles fully fledged houses. Right now, we would like to create a rag and then place something on that rag. What we can do basically is go to tile set, and we could create a pattern here, or more interesting, create a tile, or even a terrain. So let's create another terrain, call this, make it orange, call this rag, and we will paint it so that it automatically scales. So we have to paint like that. Here we don't need this, that, and that. And now going to terrain. Where is it? Rag. What we can do is place a rag, and as you can see, because we painted it properly right here, we know and gotta know which tiles are neighboring each other. So you can just, oops, very quickly and automatically create rags. So let's place one here, maybe a smaller one here. Maybe here we have some space, so let's place 3 by 3 here, maybe a smaller one here. Okay. Yeah, and then if I would like to place something on the rack, like a table, I would go to on decoration and go to, for example, a table, right? So this is now in another layer. So we have the floor, then the rack, then the, well, as a decoration, then on decoration we have that one. Cool. And basically we could add more details to it, right? You could take some plates and place them here or there, right? Maybe we'll add some stuff here just for fun, but this is the gist of it when it comes to building with the tile sets. We could add some windows here and there, so maybe here, right? And maybe here. Well, you can decorate it more if you want to make it feel more lifelike. I believe this is enough for our case. What I would like to add though are some trees. So let's grab that. Oops. Let's place it, and what we can do is create a pattern from that and drag and drop or paste a tile map selection. So now we have a pattern of a tree, and we can paint this where we need them, just here and there. Let's add those smaller ones. Maybe some stones. Right, cool. And in the very end, what I'm going to do is I'm going to use those tiles to create like a fence. Oops. That one. And it can sit in the decoration layer. In that case, layer doesn't really match. It doesn't really matter much because it won't overlap with anything. And I will create like a few openings here, be here, here, and here. Okay, that's going to be all. As I mentioned, remember you can add more, you can place like you can always place some stuff on the table to make it appear more lifelike, right? For example, let's you can add the oops, that was decoration. Let's switch to on decoration. This and this, just to make it maybe create a storage room here or something like that. Just use it to your imagination and to your will. Maybe one thing I would like to add is just to finish everything is to place the aquarium somewhere because it's really cool. So let's again select, create alternative tile, create alternative tile. I want it placed here. So we need to go to select and then transpose and transpose, and we have our aquarium. So we can place it right here, for example. Maybe add something, a little bit of plants here and there. Okay, I'm gonna call our level than when it comes to placing tiles. So in the next section, we're gonna start on working on our character and its movement. Okay, we can start working on adding our player and its basic movement. So we're gonna create new scene, search for character body 2D. We will add the sprite for the sprite representation. I'm gonna drop character PNG into it. It's a little bit blurry. Do I want it to be set? No. Let's keep it in inherit. This is fine. We also need collision shape for our player, and I'm gonna use capsule for that. So let's search for collision shape 2D. Let's find new capsule. Let's move it a little bit and size it a little bit better. Okay, this is fine. And let's name this player and save it in scenes. And what I'm going to do is I am going to write some code that will enable our wonderful player to um, to basically walk. Maybe let's first go to main and let's drop it. So let's instantiate player, place it somewhere here. Let's go back and let's start coding. So this is going to be the first script in our game. So I'm going to go app and create new folder, scripts, and there I'm gonna place player. Cool. Let me bump it up. Let me also turn on mouse highlight, and basically you can get rid of everything. Let's start by saying that the class name for this is player, and let's export speed. I'm gonna set it to 300, and then we need to handle the input. So basically right now we can set everything when it comes to the input in our game. So let's add some actions. Move backwards, move forward, move left, move right, shoot, and reload. And we can start adding the keys for that by pressing plus here. So S, W, A, D, shot is going to be mouse button left, and the reload, that's going to be R. And we have basically everything. And let's handle our input in input callback. So what we will store is we'll store the, let's see, we need movement direction. So let's create a variable here. It's going to be vector2, 0. And then we can just if the event. Movement direction is gonna be vector2 up, Okay. That's basically it. Then we will need to apply this in physics process, and we are using physics process instead of process because we're moving our character by using velocity. So we can just say velocity is movement direction times speed, and we can call move and slide. Okay, that's one thing. Other thing that I would like to add is that's rather typical in the top-down shooter, that our character rotates towards the cursor. So we grab mouse position, or do we need it? No, we just need an angle, and the angle to rotate is get global mouse position minus global position angle. Okay, and this is the angle to which should we rotate. So let's see, let's say if angle, then we can linearly interpolate from one angle to another. So we're gonna do export rotation speed and say global rotation lerp angle delta times rotation speed. Okay, and that should allow us to handle the basics of the movement. This should be the main scene. So set as main scene. Cool. Let's try this. Oh, we don't have a camera, right? But that's not a problem. We can just simply add camera to the other child here. And it's gonna automatically set and follow the player. And as you can see, we can rotate towards the cursor and we can move left and right. But there's a one problem that we will handle in the next episode, which is currently we can walk through the walls. So this seems like quite a problem, right? But this is good enough, right? And we will handle that in the next section. Okay, so what we would like to do now is add physics for our walls and columns so that there are actually obstacles. But as you can see right now, we have those ugly errors stating cannot create tile, the tile is outside the texture, or tiles are already present in the space the tile would cover. And to fix that, we can go to tile set, click here on those three dots and choose remove tiles in fully transparent texture regions. And with that, and by clearing this, should no longer have those issues. Oh, they're still here. So that's not it. Yeah, so if you have the problem that the cannot create tile, the tile is outside of texture, what you might need to do is to go to the tile map, tile set, delete it, then press Ctrl Z to reload it again, right? And then in the tile set, you should have that exclamation mark, and now you can go to those three dots and choose remove tiles outside the texture. And that should clean up the texture. And now if we press play, we have no more errors. This is a 4.2 right dev, so it comes with some issues, but there's always, or at least I think there's always way around this. But with that problem gone, we can continue working on our walls. So what we need in our tile set is to paint the collision layer. So we need a physics layer for that. So let's go to actually, let's set up the physics layers first, maybe. So project settings, general, 2D physics, and we'll need some 2D physics layers. So that's gonna be player, obstacle, enemy. Let's do attack, area, bullet, pickup, and extract. And I leave the layer 4 empty because I wanted to add interactions with doors, but it became a little bit too problematic, so we leave that off. Okay, with those defined, we can go to tileset and paint and find the, let's go here, let's add the physics layer, and let's set the layer to be obstacle here in inspector, and now we should be able to paint these. So basically, let's click on all of those. I believe we're using most of them, so you can just paint across everything, just in case we're not using those, but we're using those as a column. And here we can add the physics layer by just adding more points. So press plus to add points. It doesn't have to be perfect, but just good enough. Okay. Let's drag these. Okay, click plus. Maybe bring that closer a little bit. Here, reset to default shape. Okay. And with this, we could also add snapping. And we need more division here. Let's see, we can expand this. And it doesn't match the grid. 32, that's pixel perfect. So now it snaps to the right place. And that's good enough. So let's try this now. You're moving, and we still can go through the walls because we have to set up the collision here. So we're a player and we are colliding with obstacles. So in the player, inspector, collision, set the layer on which your character resides, and then the mask. So what should our player collide with? And that's good. Cool. Other things that we should collide with, right? So like I can see that our gun is clipping into the wall, so that's not really perfect, but we can fix this. Let's go to collision shape. Let's see, this is because we set the collision to be only here, right? But we can change it easily. What we can do is delete the collision shape, and what we need is collision polygon, and then we can paste it here and start working with the polygons. So let's add this. It's more complex to compute than simple shape like an ellipse, but this is should make our collision more precise. Let's try this now. Yeah, as you can see, we are no longer clipping into the walls. Perfect. So this is our collision, but we need to add this to more of our decorations. So I will do this right now. And I will speed up this part of the video because it's pretty much all the same. Okay, let's check whether we missed something. Oh yeah, because this is alternative tile. And this. Yeah, so we need to add those two alternative tiles. And also to this. Okay, I think that should be it. Please remember, if you're using some additional tiles from the tile sets, you have to add the physics layer, because otherwise your character won't be colliding with it. So let's test how this works now. Oh, for example, here I forgot about the oval lamp, and I forgot about, yeah, about the kitchen. Nice. And just to fix one thing, I can see here that I missed the table. So let's go to decoration. Let's find the table. And then on decoration, I wanted to place zip here. Perfect. So yeah, this was a little bit of work. We will again have to set additional layer. Oh, and of course, I believe here's gonna be a problem, right? Because if we count that as a window, yeah, you have to add that. And I believe that's that one. Mm, and there's this one. Mm, perfect. And then for the fence. Let's try that. Okay, good. So that's it. We have the physics layer and the collision set up for our game. I'm going to see you in the next section where we will start working on our AI. There's one last issue that we should discuss, and it is from time to time, if you play the game, you can see those, well, you cannot see them now, but there's those black lines between like tiles, right? We don't see them right now, but in previous section you can easily see them. And if that's the case, what you can try to do is to go to project settings, search for pixel, and in rendering 2D, try to set the snap 2D transform to pixel and the vertices to pixel on, and that might help in your case. So this is how you can get rid of that. In this section, we will start working on our zombie enemy. This will include a few moving parts. Mainly we need to, of course, add the character body, the sprite, the collision shape, but two very important parts that we need to include is the navigation for our zombie enemy to move on our tile, and also the state machine. And here is short information for you that I am not an AI expert. I'm definitely not a professional game programmer, but we'll try to program our AI to be sort of smart and in a way that you can easily extend it. So let's get started. We will start by creating new scene. As a root scene, let's choose character body 2D, and let's name this zombie enemy. Let's save it. And what we need is, of course, the visual representation. So let's add the sprite 2D. And that's gonna be, let's start by adding zombie standing PNG as a texture. Okay. And then let's add collision shape. And in our case, I believe that here the capsule, or not the polygon, sorry, but shape, and in this case the capsule should be good enough. So let's extend it to match our zombie, and I believe this is fine. Perfect. So we will need to get this thing on the road. So let's place it somewhere. Okay. And in editor, we can, what we have to do first is to allow our zombie to move, just move somewhere, right? The problem is we have to also limit where he can move because we don't want him to move on a tree or inside of our walls, right? So basically there are tiles on which he can't freely move on, like the tiles of the floor, but without any obstacle, right? And also trees and walls should be a no-go zones. So to set all that, what we need is to add the navigation information to the tiles that we use, okay? So what we can do is go to tile map, and then we need to find navigation layer and find a navigation layer and create one. That's the layer we'll use for our AI, because right now it doesn't know where it can move, and we need to specify the regions in our tile map where he can move. So let's go to tile set first, and let's handle the grass first. Let's do navigation layer, and basically we could simply paint this 1 2 3 4. Perfect. But there's going to be a slight problem with that, because not all grass tiles should be available for navigation. We can turn that on. Not all tiles should be available for our zombie to move. Some, like those tiles where we have placed a tree, should be off limits. And we can do that easily by simply going to a tile map, and we can press create alternative tile for each tile that corresponds to grass. And in this case, we will not paint navigation layer on those. So these are no-go zones in our grass, while the standard ones should be available for our zombie to walk on. So going to a tile map, I'm just going to take one of the tiles and set this to drawing mode, and just click everywhere in the grass where I think our zombie shouldn't be allowed to go. So basically under each tree, right? And you can change the tiles, but it doesn't really matter. So you can choose one from those here. So just make sure that you get underneath each tree. Okay, I believe that's it. Then we have to take a look at our floor tiles. So for example, this tile is off limit because it has a column on it. Here we have a couch, so this is also banned from the movement, right? So what we can do is start by creating just an alternative tiles. So first we need to place the navigation information on our floor tiles. And then I'm going to create alternative tiles. Oops. We're going to select and clicking create alternative. And then just paint those places that have some kind of obstacle. So here, 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 and that covers that that room, and then here we have that color, and this, and this. And here we have this orange one. And you don't see any visible change, but I'm just using those tiles, alternative tiles without navigation layer, to make sure that our zombie is not allowed to go there. Oh, and also I'm using the wrong color. And again, this is this yellow one. Okay. And then here also I'm taking a look at which tiles should be removed from the navigation. And this one. And I believe that's it. Okay, so we cleared our navigation layers. Now it's finally time to start coding. So I will start by going into Zombie, and we'll create a script here, and we will call this zombie enemy. Perfect. And we will expose a few things here. We can get rid of everything. We can provide the class name. And we need some information here. So basically there's going to be a lot of variables exported here to see in our editor, and to keep everything nice and tidy, what you can do actually is to group them. So you can write export group. I'm going to write the first one down as locomotion, and I'm gonna export rotation speed. It's gonna be float. I'm gonna export wandering speed. I'm gonna export navigation position, or more like navigation target. And I'm gonna export chasing speed. Okay, and now you can see that they are all nicely grouped in that drop down. So this is really cool. Okay, let me think. We will definitely need something called navigation agent. And this is the node that's gonna handle the algorithm for finding the proper way on our tags in our game. Alternatively, what we could do is write our own algorithm for navigation, like a star algorithm, but for the simplicity's sake and for the time's sake, we're going to use navigation agent 2D. So let's start by writing ready function. And what we will need is to get the navigation map from the time map. And to make it easy for us to find the time map and maybe not always rely on direct paths, what you can use is find the groups, which is the groups are pretty much like tags. So I can go into the time map, click on it, go into node tab, groups, manage groups, and I will add time map group, and I will add time map to it. Perfect. And then I can get access to the time map by using, let's call this navigation map, because that's the property we are interested in the time map. And I can say get tree, get first node in group, and the group name is tilemap. That's the one we just created here. And then I can say get navigation map from layer 0. And let's print and see what we can get. So let's clear all that. And we actually get something, right? It's not null. So that's very, very good. Okay, and we can start setting it up. So for the AI and for the navigation, what we have is we have a navigation agents, which are like clients, and they communicate with something which is called navigation server 2D, which is like a central server that is calculating the navigation for the agents, right? And this is like kind of like client server architecture. And we can use this by accessing navigation server 2D agent set map, and I will call this navigation. We need the reference to navigation agent in our zombie. So let's go here and let's have a reference here in onReady to navigation agent. And now I can get access to it, its identifier, by calling get read. And then I can pass the navigation map. And this is also, to be honest, not the navigation map as the map itself. It's rather like navigation map identifier. Okay, and then I can say navigation agent 2D set navigation map. Okay, and that's pretty much it for that part, because we won't be, oh, there's also one more thing I wanted to add, and this is a variable called current speed. And for now we can just say that the current speed for the start is equal to wandering speed, because we won't be coding all of our AI in that one script. Actually, I consider it kind of maybe not bad, but anti-pattern to put all of your code in one script. What we'll try to do is we'll try to split it reasonably, just to make sure that we are not putting too much code in one place. So what we'll do is we'll introduce something called the state machine for our game. And this is one of the ways to make AI. It works when the AI is maybe not so complex. There are other ways to write AI, like, for example, how do you call it? The blackboard methods, so the behavior tree, and then goal-driven AI. But what we'll use is a state machine, which is controlling few different states of our zombie. And what we will have is a idle state, then wandering, then chase after the player, and attack. And each of those states encapsulates some kind of behavior in our game, and then the state machine is basically orchestrating them, right? And each of those states has some reasons to enter to that state and some reasons to leave that state. From time to time, it's going to be a timer. From time to time, it's going to be like sensing the player or some kind of game state changing. For example, if our zombie get shot by the player, if it's in idle or wandering state, it's gonna automatically go into the chase, right? So we'll be switching those states and basically creating a graph where each node is a state, and then we have transitions from one state to another. And here we have some conditions for the transition. Okay, so let's get going, and I'm gonna add a child node, and that's gonna be an empty node, and we will call this state machine. And then underneath, I'm gonna add the child nodes for all of our nodes, and that's gonna be idle, then wandering, then it's gonna be chase, and attack. So let's start by actually writing the state machine. Do we need this? Yes. So let's go to scripts and create a state machine. State machine. Perfect. And this is going to control our states. So let's start by creating state machine, and we'll have a signal informing us about transition from state to state. Transitioned state name. So this is triggered whenever we transition to a new state. We have state name for the current state. We have ability to provide a node, or more specifically, node path as initial state. For example, in our case, that's going to be idle. Then we will need also, what we'll do is we'll add a label informing us, but do we need it? Or we could add this. We'll add a label that will inform us about the current state, just for debugging purposes. So let's get the reference to that. And we will also need a state. Is equal to get node of initial state. Perfect. And we can leave that for now, but we'll create another script, but will not attach it to anything yet, because that's gonna be like our abstract class that we will use for all other states, and that's gonna be simply here, and we'll call this state. And this is where the inheritance in GGScript comes in. It doesn't have like the true abstract classes, like for example in Swift or C#, but we can create one. So I'm gonna create a class name state. It will always have a reference to the state machine to the state machine that controls the given state. It will have update function, the delta float, and what's the name? It's update, not process, but it will basically do the same thing that process. And then we will do physics update with delta. Also returns void, and also make it pass. And then also enter what should happen when we enter the state, maybe with some kind of additional information like message. And then pass, and then exit also returns void and also pass. So we are not implementing those functions here. This is just a blueprint, like a parent class. But what we will do is we'll actually create the states, the script states here, and those classes, those scripts will inherit from that class. So here I can actually make the state of type state now that we have it defined. And then we can do ready. Okay. And I can say for child in get children, we need to assign the state machine to each state, and we can say a state array. Can we do it? Expected. Can we do array of state? Okay, now we should, yeah, now we have autocomplete. Assign self. So here where we have the reference to the state machine, right, we are actually assigning this class to it so that we always have the reference to it. And we call state enter. Okay, no message there. And then we have the reference to a current state, right? So in process, we say if state has method update, we call state update with delta. And this is pretty cool feature of GDScript language where, well, it's not really statically typed. We have some typing, but it's, you know, it's rather weak, but we can dynamically look up methods or properties to make sure that that given method exists in a given script. And this is something called DAC typing. Basically, if something walks like a duck and talks like a duck and flies like a duck, it's a duck, right? This is one of the methods of handling dynamic objects and checking what they actually are in programming. Okay, so then we can say physics process, and it's pretty much the same. State has method physics update, state physics update with delta. Okay, and then we have a very important function that we'll use to connect between state called transition to, and we'll get target state name and maybe some message type of dictionary. And if not has node of target state name, target state name, return. And then we can just assign state name to target state name. If current state name, current state, sorry, has method exit, so maybe we should do some cleanup while leaving given state, call state exit. Then we can say that the state, current state is get node target state name, state enter with the message. So basically we're calling this is like on ready for our state, right? Or start, or the start of our state function or state script, sorry. Where are we? Here. And then also we can say that state label text is equal to state name. And to make sure everything is looking nice, let's see how our label, for example, wandering. Okay, it will be visible. Perfect. And basically that's all that we need for now. Now it's time to actually implement the states. So let's start with the idle state. I'm gonna add a script here, but one thing, it should not inherit from node right here. It should actually inherit from our state. Okay, and here it says extends, providing that ugly path, it will work, but we can just say extend state, and that looks way better. Okay, so how should our zombie behave in this idle state, right? So my plan for it is to make him just turn randomly right, left, and right, and then after some time passes, move him to wandering state. And that's the basic loop of our zombie. So he starts idle, rotates left, maybe he rotates right, sometimes passes, and then he moves to wandering, which is another state. So we will need, what we will need is something called random timer, and we will need to create one. So let's start with a simple timer. Let's make it a child of idle, and this is going to be idle timer, and we will attach a script to it, but we'll call the script random timer. Okay, it's going to be very simple script. We will export, we'll make a class name, random timer, and then export var min time float set to 1, and export var max time float set to 4. And we'll have only one function called setup. We'll get random wait time, which is going to be randf range, so random from min time to max time, and we'll set wait time to random wait time, and we'll start the timer. Also make sure that your timer is set to be one shot in our case, and it's not on auto start. Okay, and we will add another timer, but this time if we start writing timer, you will see the random timer as a blueprint for a timer, because we already extended that. So use that. We'll call this rotation timer, and I'm gonna set this to one shot also, and 0.2 and 1. Okay, with all of that set up, we can finally start working on our idle state. Okay, let's get the references. Perfect. and we will have a few things here. So we will need rotation speed as a float. We'll need information about is it rotating. This should be like that. Then rotation degrees. We set it to 0 and allow rotation set to true. Okay, and then we will work with the callbacks. So first is of course enter, right? And again, this is because we are inheriting from that one. Okay, and we'll basically override the function in our base state. So enter. Maybe we have a message here just to match the signature of the function. Void. Okay, so first we have to disable the velocity of our zombie if we enter the idle state. And we can get the reference to our character body by calling the owner. So there are two options in GDScript. You have get parent, and get parent, it will give you the immediate parent of the node. So for idle node, this is going to be state machine node, but we also have a reference to owner, right? And we know that the owner of all of those nodes here is the most top node, in this case, character body to the zombie enemy. And I can disable any movement by specifying that the velocity is set to vector to 0. Then I can get the rotation speed by saying that owner as zombie. Also, I could have casted it here too. And we have a space here. Is taken from the rotation speed. And why are we doing that? Well, instead of providing rotation speed just here, this is basically for the extensibility, because if you take a look at the main and click on the zombie enemy, what you have exported here are the variables only from the owner, from the topmost node, like rotation speed. If I were to export some variable here, like this, right, you will see it's not popping, right? Because this is the node nested inside of another node. So basically, this allows us to set the different rotation speeds in the main for different zombies, right? But it will be used in that deep nested node. So I'm just reading from the value from the owner, which you can set right here. Okay, you can say idle timer setup, because we can cast this to random timer. Okay, you can say allow rotation is true. And then rotation timer also set up. Okay, we'll also need our exit. So what happens when we leave? We set the is rotating to false, allow rotation to false, rotation timer stop, and idle timer to stop. Okay, and then we will do only one thing on physics update, and this is, so this is physics update. We check if we are already rotating. If we are not, then just return, because there's nothing else to do. If we are rotating, then rotate while idle. Okay. And we will need to write that function. Cool. So first we need to check if we are rotating and we're allowed to rotate. Then we can calculate the rotation angle, which will be equal to, you can lerp angle degrees to rad. We can take owner rotation degrees and current rotation degrees, and just apply the weight. So this is delta times rotation speed. And then we'll just set owner rotation to rotation angle. Okay. The one problem is how do we get the rotation degrees, but we'll come back to that in a second. And then we need to stop the rotation, right? If, let's see, if absolute value float of owner rotation degrees minus rotation degrees is less than is less than 1.0. We set the is rotating to false, so we stop the rotation, and we set the rotation timer to set up again. Okay, so what is happening here? Basically, we'll not be animating the rotation with some kind of, I don't know, tween or animation player, but what we can do is linearly interpolate, right, the angle. It has to be provided not with the radians, not with the degrees, but rather with radians. So we convert from degrees to radians. So basically from, like, if you don't know, the radians are this mathematical construct where 360 degrees is like 2p, right? And then you can use that to calculate the angles. And how fast should we match, so how much should we interpolate in given frame is calculated by that weight. And then if we decide that we turn close enough, so the owner rotation degrees and the rotation degrees to should we turn to is close enough, we just stop the rotation. Okay, and to make it all work, we need few other things. So let's go here, and we need to set up the listeners for our wonderful timeouts. So connect one timeout, connect the other timeout. So those functions will trigger when the wait time runs out in our random timers. And on rotation timer timeout, we will do something like try rotating. That's how we'll call that function. So try rotating, and I tend to add this try a prefix to a function when the given action is not certain, right? And here, if we don't allow rotation, we simply return. And then if it is rotating, oh, it's the, oh my God, we connected those to the wrong place. So my bad. Let's disconnect this and let's disconnect that, because Godot by default, if you try and connect, will select the topmost node, but we are trying to trigger those timeouts in the idle. So we have to be very careful to which node we're connecting our timeout signals. Okay, now it's fine. So once again, try rotating, and then we'll just write this function. And we will say if we don't allow the rotation or we are rotating, return. Other than that, start rotating. And we will write start rotating function. And we will get the rotation degrees by saying owner rotation degrees plus randf range from 45 to 300. So basically we're taking the rotation from the owner, from the zombie enemy node, and adding something to it. And then we're also saying is rotating is true, because in the next physics update callback, in the next frame, we will start rotating, right? Perfect. And then we should do something on idle timer timeout. And what we'll do is we'll just transition to wandering state, and we will stop the timer. Do we need to? No, we don't need to, because that's going to be handled by our exit. Okay, so that's the first state in our state machine. One thing left probably is to maybe here we can say on ready state label text initial state, and that should be correct. And let's see whether this is working. Invite set index with value of type node set machine. Let's see. Child state machine. It should have reference to it. I think I know what is wrong. We did not provide the initial state, right? So we can do this by just clicking assign here and choosing idle. And now it shouldn't be broken anymore. But it still is, but definitely we were missing that one. Oh, I think I know what is wrong. We don't have the scripts yet for those nodes. That's why it's breaking. So let's just create empty nodes here. Make it inherit from state, create, let's see, do we need class names? Could use class names, but not really. That should be enough for that working. Also the same, can stop that and then add chase, but it's inherit from state. And also here attack, it should also inherit from that. Okay, and now let's try, and it is working, and you can see that our wonderful zombie, let me disable navigation for now. Our wonderful zombie is in idle, it turns, then it turns to wandering, right? And probably if we change the timer here to be way longer, it should turn 2 times. Now it's switched to wandering. Let's see, idle. Okay. So let's check our idle. We rotate when idle, and the rotation timer should be set up again. And then it should time out again. Oh, but this is rotation. Let's see. Bump it up even more. Turns. And it does not turn again. So let's see here. You can print the difference between the degrees. And it should drop to 1. And it should turn. Yeah, now it's working. Perfect. So we have that one working, and this is very long section in itself. So I'm gonna stop it right now, and in the next one we'll work on the wandering mechanics for our zombie. Yeah, see you there. So with wandering state written, now it's time to handle the other state. I mean, with idle style, state already written. Now it's time to handle wandering state. So you can go to the script that we previously prepared, and we can start and add the references to the things that we already need. So definitely what we need is the reference to the navigation agent, because the navigation agent is going to be the one basically plotting the path for us. And then we'll also need wandering radius, and I'm gonna set this to 500. Again, what we could do is read that value from the owner. So if you'd like, you can go here and add it as a property that will later read in a wandering script, just like we do with rotation speed here. Okay, so we need enter function. We pass nothing here. And basically, on the very start, we call the function called move to next random location. And we need to write it, obviously. So move to next random location. What we will need is random position in radius, and we can say random position in radius is equal to get random position in radius, and I'm passing to here wandering radius, but I don't really need to because it's in the scope of the script. But it's pretty much always nice if you can to pass the arguments explicitly into the function. So let's write that function. So basically how will this work is that we have our zombie, and in a radius, in a circle of a given radius, we'll try to find a random position for him, and then he will plot, change color, and then he will try to plot how to get as close to that position as possible. So get random position in radius with wandering radius as a float. The function should return vector2 with a global position of the owner. So owner global position. We find the random angle, which is rand f times 360, and we say random point is vector2 from angle random angle times rand f range from 1 to max radius, and we should have that defined because as wandering radius, okay, plus global position. And then we need to find the navigation point that is the closest to the random point we found. So navigation point is equal to navigation server 2D map get closest point, and we say navigation agent to d get navigation map random point, and we return the navigation point. So what we do is we get the current zombie position and find a random angle, and then we find a random angle, a random point in a random angle that is maximally as far away from our current position as wandering radius, and then we're trying to find the closest possible point on the navigation map to navigate to that point. It's not always gonna be perfect, right? Because maybe we found a point that is in the wall or in the obstacle, and we don't want our zombie to move there. We would like him just to move as close as possible, taking in regard to the navigation map that we provided to create it in a time map. Okay, and with that, we can write our physics update. Make sure that you're using physics update and update, because that's what we defined here in the state. The state machine is calling those in process and physics process to make sure that only the given update for a given state that is currently active is getting called. Okay, and we can write something like this. If navigation agent 2D target position is not equal to vector2 0 and navigation agent is navigation finished, loop is not true that the navigation agent 2D is target reachable, we just transition to idle and we return. Okay, so this means that there's no target position set, right? And if we don't have any position set, we should go to idle. Or basically, do we need that? I think yes. And we have other two cases. Is navigation finished, meaning where we reach our point, or there might be a case there is some kind of mistake on our part and the target we provided for our wandering is not reachable. Then we should just fall back to idle. Okay, else we can say var next position is equal to navigation agent 2D get next path position, and here when we get that random position in a radius, we need to make sure that we say navigation agent 2D target position is equal to random position in a radius, and then I can just call owner as zombie move to position next position. So this is going to be written in our zombie enemy, because here we'll handle the movement on its own. So move to position. Let me see. Move to position, we'll get target position as vector 2, and we will calculate the motion that we need to do. So motion is position, direction 2, target position plus times current speed. Navigation agent 2D set velocity, motion, look at, and we'll say target position just to make sure that our zombie is facing in the right direction. Then we say velocity is equal to motion, and then move and slide. And if we did everything correctly, we should be able to transition to wandering and actually get our zombie moving. So let's try this and see if we have any errors. So we're idle. Oh, and I left the timer to be too long. Maybe let's start with visible navigation and then visible paths, and then go back to idle and turn this down to 1 and 4. Let's see. And we're moving, and we're idle again, and we're moving. And there's gonna be one problem that I can see, is that we need to set up the proper collision for our zombie. So it exists in a layer called, where is it? Enemy, and it should collide with player and with obstacle. Yeah. Okay, let's try this again. Okay, and now we have our zombie moving, and he's stuck here, as you can see, and he cannot reach his target, right? Like he cannot like avoid that corner trying to get where he wants to go. Okay, so how we can solve that? We can solve that by going back to our main, to our tile map, and taking good look at our navigation. So let's see, tile set, and then navigation layer. And as you can see here, now it's taking the whole tile. So what we can do is actually, let's change it maybe to, I don't know, 16 or maybe to 4, and let's just place this in the middle for navigation, right? And make sure that we have that padding around it, because we have to provide a way for our AI to avoid corners. So here, and then we need to provide the information for our project to actually link those tiles with navigation, even though we have that margin here. So we can go to a project and find out about navigation. Now let's see, 2D navigation. No, sorry, this is here, navigation 2D. And here we have to provide some changes, right? Let's do advanced settings and change the default edge connection margin to be 32. And now it should connect those nodes, even though there's a separation between them, but they will be detected by the AI as shrinked, and it should allow the our zombie to move around the corners. So let's see. Okay. And he should not get stuck on the corners anymore. Okay, maybe let's also test, let's disable the navigation because it doesn't help at all. What we can do here is search for debug, or maybe where is it? Process, edit materials. Oh no, here in zombie enemy, in navigation agent 2D, we can enable the navigation to see the path that our zombie will be taking, and let's put him into less favorable environment that is way complex, like here, and let's see his behavior. Okay, and now we can see where he's moving. He can move around the corner, very nice. And yeah, a little bit of fighting, but it's all right. He was able to move. Now he's moving outside. Perfect. So we have our wandering now working. This is really cool. The next state is the chasing state that I would like to add. So let's do this in the next section. In this section, we'll write the functionality of our zombie detecting the player and chasing him. And to be honest, I wasn't sure how to achieve that. Thankfully, I got the inspiration and information from the, let's see, GD Quest, Vision Raycast 2D, right? So, all thanks to those guys and their wonderful tutorials for helping me how to figure this one out. So we will need few things in our zombie enemy. First thing we will do is we'll add Vision Raycast 2D node. So Vision, Raycast 2D. I'll call this Vision Raycast 2D, and this might simulate the vision of our AI. So enabled, yes. Exclude parent, yes. Target position is actually to be 174. That is correct, I believe. And then, sorry, 174, it should go to front, of course. So we align it with the x-axis, and the collision mask is set to player, and we allow to collide with bodies. Yeah, because bodies and areas, that is fine. Okay, and then we have to write the code to actually try and detect our player, and we'll do that since this is not really belonging to any state, or actually it belongs to two states. We'll write it in our main zombie enemy script. So let's get to physics process, or even maybe do we use physics in that function? No, so I'm gonna say do this in process. Okay, and here we just call search for player with raycast, and let's write that function. Okay, so what we would like to achieve here is our wonderful zombie scanning some area in front of him with a raycast. And we could do with a single raycast, or we could create multiple raycasts to do it, right? And of course, the more raycasts you are using, the more computationally heavy it gets. So to get that kind of scan of a given area, right, what we can actually do is, how do you change the brush size? Oh, I'm not sure. Okay, let's just, no, that's not it. That works. Okay, so what we will do actually is we will create a single raycast, but then in time, or rather in a set of a single FPS, we will move it down, and we will kind of try to swipe everything down, right? So we'll just change the point to which our raycast is pointing in a span of a single call for a function to make it scan the wider area in front of it. And if it detects a player, right, if it detects a player, we'll move to chase state. Cool. So how to do that? We will need a few variables here. So let's do export group, and we'll call this scanning for player, and we'll export var angle cone of vision, that's 19. Export var max vision distance to 50. We'll export var angle between rays. Yes, and then what we need is a reference to the Raycast2D itself. And we have everything, and we can start working. So first, we need the reference to the state machine. And we can get that by simply importing it. So let's get the reference to that. And then I can say if state machine state name is not equal to idle and state machine state name is not equal to wandering, basically so this means if we are chasing or we are attacking, we are not scanning anymore, return. And then we calculate how many casts do we need. And this can be calculated easily with angle cone of vision divided by angle between rays plus 1. And then for index in cast count, we'll just cast the raycast, make it detect the player, and then move it. So cast vector, where we will be casting our raycast, is max vision distance times vector2 up rotated rad 2 degrees angle between rays times index minus cast count divided by 2. Okay, and then vision Raycast2D target position is cast vector, and we need to actually force raycast update to provide those new values, and then check whether we detect something. If vision Raycast2D is colliding and vision Raycast2D get collider is player state machine transition to chase. Okay, and that should be it when it comes to detecting our player. Let's see, in the vision raycast, let's see, can we get this and this? Also, does it have any debug? Not really. Okay, let's see. You can see it's scanning. You can see the scan. right? It is wandering, right? And then, yeah, now it's chasing me, or at least it should. But let's see. Let's just print those as vectors. So again, it has detected me, right? It changed its state. Wandering, and now it's detecting me, right? So we basically have to add few things here to make it work, but we're getting closer. Let's see. Wandering. No, we can already start writing the chase, I believe. So we have a script for that. And we will need information about how often should we update the chase target. But let's start by just bringing everything that we need. So we'll need the reference to navigation agent. We'll need the reference to a sprite. And that's it for now. And we already can get the textures because I would like to change the look of the zombie at least a little bit when we are chasing. So we have zombie walking as a texture chase, and then texture default is preload zombie standing. Okay. So about the chasing mechanic itself, right? Because I don't want my zombie to chase my player indefinitely because our player will be running away. So if the player gets enough of distance from the zombie, like for example 250, there's a random chance that the zombie will stop chasing and will go back to being idle, right? So, oh, you're like 250 away from the zombie, now you have like 0.5 chance it will stop chasing you. Maybe it's not the best mechanic, but I found out it to be pretty nice. So let's start by implementing enter. First thing, we will need to check if owner is not quit for deletion, because this will happen when we kill a zombie when we introduce the shooting mechanic. So this is just a safe check. Then we need to write our physics update. Delta float. Okay. First thing we'll do is we'll say first we'll see if navigation agent 2D has finished its navigation. If so, we'll try to stop chasing. Let's see. Try to stop chasing. And to do that, we need to know how far away the player is, and we'll return bool. So to get easy access to a player, what we will do is we will simply add it to a group. I'll create a player group, and I will add a player to it. Nice. Then in chase, I can do player is equal to get 3, get first node in a group player. And if the player is null, just a stupid safe check, return false, meaning we will not stop chasing, we'll continue the chase, right? Or rather, if player is null, we should stop chasing, really, because there's no player. Let's indent this correctly. Then we need to find out the player position. Then we need to figure out the distance to player. Global position, distance to player position. If distance to player is greater than distance to stop chasing, which we can define, right? And we can define this as a const. It can also be exported in the owner. And we also need chance to stop chasing, which is like 0.5. And let's see. We'll simply return stop chasing. Other than that, return false. Let's see. If try to stop chasing, simply return. Okay. And this is not needed, but we need to implement stop chasing function. And this is pretty cool. I will just do stop. Basically, you can just call stop chasing and return true. And here in stop chasing, we'll just pick a random new state. So new state is equal to idle and wandering, pick random, and state machine transition to new state. Okay. What else do we need? We need the exit, and we need we also periodically need to update the information about the target that we should move to. So let's go to chase. Let's add a node, random timer. Call this random target chase update timer. That's a mouthful, but this is all right. And I'm gonna configure this to be between 0.5 and 3 and just say this is one shot. And let's connect the signal. So go here, find the proper parent node to which we connect. In this case, this is chase node. And then on timeout, basically we'll call a function start chasing. But here we also need a reference to this. And on exit, we can just call stop. We can change the texture back to sprite2d, texture default. And we also need to change the owner current speed to be equal to owner wandering speed, because I would like my zombie to be faster when I'm chasing. So then on enter, what I will do is say sprite2d texture equal to texture chase, and then owner current speed is equal to owner chasing speed. Perfect. That leaves us with start chasing to be written. Okay, let's see. Start chasing. So basically, what we can do is write function like player get3, get first node in group, type player to get the access to player, and then if there's no player, we can just return. But we take the player position and I do navigation point. I'm trying to find the closest possible point on the map. So navigation server 2D, map closest point, navigation agent 2D, get navigation map, player position. And we set the navigation agent 2D target position. Oh, this should be double. Navigation point. And then we set this again. We can cast this to random timer, cast this to navigation agent 2D, cast this to sprite 2D. Okay, so that should work. And what we will do is we'll call start chasing here at the start, but also each time, let's see, each time the timer runs out, we will see whether we should actually continue our chase. Okay, let's see how this works. Okay, let's see. It is chasing, but it's not moving actually towards me. Let's see. Oh, this is because we, of course, did not finish our physics update. Let's see. we have that. Okay, and basically what we can do here is just whenever the navigation is finished, we just need to say it's the player. So basically we can copy all of that. Here. So whenever we finish our navigation, we try to continue chasing, but then we just say next position navigation agent to D is get next position, and we call owner as zombie move to position next position. I'm wondering, do we need this? Because it should trigger when the navigation is finished. Let's try without this for now, and let's see how this works. Okay, you're chasing. Yeah, and it has some problems when the navigation is finished. So let's try with that. You're chasing. Yeah. Okay, yeah, it should update every time the navigation is finished. And now we should be eaten by a zombie, right? But yeah, this is working properly, and now it stopped chasing me. One thing, this is pretty much the same as what we have here. So let me abstract this away, and I'm gonna call this set set next chasing target point, and you can do that. And also then if the navigation is finished, we can do that, and now it's just way cleaner. So yeah, now we have our zombie. If he detects me, yeah, he will start chasing, and I have to run away and try to shake him off. And if I run away far enough, yeah, he gets back to idle and back to wandering. Perfect. So we have our chasing state done. In the next section, we will work on our attacking state. Yeah, and then we'll introduce the health, shooting mechanics, possibility to shoot the zombie. Yes, there's still a lot to do. So let's get to it. So in this section, we will handle the attacking state. And for us to move into attacking state, we need to have a trigger for it. So what we will do is go to our zombie enemy scene, and we'll add a child node, and this is going to be area 2D. I'm going to call this attack area, and I'm gonna add collision polygon 2D, and just create a simple polygon shape that will be our attack area. And if you would like to use the exact same values as I do, you can just go to polygon and packed vector to the array, set the size to 3, and we'll specify a triangle, and it is going to be 45, 0, 0, 45 minus 25, and then also 45 and 25. And basically, if that area detects a player inside, if we are chasing, if we're currently in a chase state, that's gonna be triggered to transition into attack state. So let's click on attack area 2D, go to node, and we will connect to the signal body entered. Connect to it by choosing the chase state here. And here in our chase, what we'll say is state machine transition to attack. Also make sure when checking the collision in the attack area to set the proper layer. So it exists in a layer of attack area, and it is detecting the collision with a player. So that should be good. Let's check our player collision. I think we don't need to really update that, but we'll see. So yeah, let's try this. Let's actually get into the attack area, and yeah, it changes the state to attack. So this is perfect. We can also go to zombie enemy and get rid of that print debug. We don't need it anymore. And what is left for us to do is to actually implement the attack. So what we will need is the reference to a sprite 2D. Okay. And we will need also some information from our zombie owner. So let's get to it. And what we need actually is the set of properties for attack variables. So export group attack and export. We'll export range so that we have a slider with attack speed and damage. How do you say damage? The amount of pain. Attack damage. Let's set it to 3. Okay, and if we export range, then you will see here that what we have in our zombie enemy, we have sliders, which is very, very cool. Perfect. So we need to get those informations here in our attack state. So I can just say attack speed it looks wrong at oh, okay, that's the word. So then it felt, yeah, it felt wrong, but okay. Attack speed, attack damage. You have to excuse me from time to time. English is not my native language, as you can tell. And we could use a timer, but you don't always need to use a timer whenever you're doing some time-related actions. And I'm going to show you how to do it with a different approach. Time elapsed. And time between attacks. No, that was a yawn. It's very, very late into the night right now, and I don't really have much time to record this, so I have to do those very late in a day. Okay, let's transition those wonderful properties from our owner. So owner as zombie attack damage, time between attacks is equal to 0.3, this is like the base value, plus 1 divided by owner as zombie attack speed. Basically, the more of attack speed you have, to shorten the time between attacks. Okay, and then enter. And we could also do that on enter, but there's a chance that we will be, instead of doing it in on ready, but we'll transition back and forth from and into attack state multiple times, and there's no reason why we should reassign those values multiple times. And on enter, we should just call attack. Okay, so attack function. First, get the reference to player. Player, it's get free node in a group player. And then if we have a player, which we should have, and player has a method called take damage, then we will call player take damage with attack damage. And just to make sure it works, we will go to player here and we'll add a function. For now, we'll just print damage. We'll handle the health system in the upcoming section. Go to attack. And then we will do, because we don't really have animation for our zombie to visualize attack, so instead I decided to give him like this blink of color, right? So we can just say attack twin is equal to get tree, create twin, attack twin property of sprite 2D, modulate, we'll change the color 115,001 with the time of 0.3, and then we will chain that twin with the next twin that will bring our color back to normal. Sprite 2D, modulate, color white 0.3. And that should be it for now, but we also need exit, where we will set the time elapsed to 0. And then in physics update, instead of using a timer or timeout signal, we'll simply calculate how much time passed between the attacks. So physics update, delta, time elapsed plus equals delta. And then I can say if time elapsed is greater than the time between attacks, this attack, and set time elapsed to 0. That should handle our attacking state, but we also need to transition from the attacking state back to chase. And that's going to happen when our attack area sends a signal of body exited. So connect to attack this time, and on body exited we could do the safe check but it's not really needed. You can say state machine transition to chase. And that should be it. Let's see how it all behaves. So we are chased, we are attacked, 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 and we are chased, and we are attacked again. And let's try and lose our zombie. Not chase me anymore. Go away. And let's see. He's wandering again. He's chasing me again. And he's attacking again. So yeah, we have a basic loop of behaviors for our AI, for our zombie. This is really cool. I'm very happy with that. The next we will add the shooting mechanics and health systems, so both our zombie and our player can take damage. We'll start working that in the next section. In the last section, we finished working on our zombie AI, and right now we will allow our player to take damage. So we'll start by going to player scene, and I'm going to add another empty node and call this health system. And we are going to add a simple script to manage the health of our player. Let's start by adding class name and we will need two signals. One for when the player died, the other for when damage is taken. And we will create a base health pool for our player, and then current health. When ready, we'll just assign the current health to base health, and then we'll allow to take damage. And if the current health is below or equal to 0, we'll emit the information that our player has died. Okay, that's it for now. What we can do is go to our player now and get the reference there to the health system we created. So we can just do already health system as health system. And then in take damage, we can just call health system take damage. But of course, now we have that simple system set up. It would be nice to have some kind of visual representation for it. So let's go to main, and here we will create a new node. Let's search for canvas layer, and this is going to be our player UI. We can actually save branch as scene, go to scenes, save it, go inside, and we will start working on our UI. So I'm going to start by adding marking container, and I'm going to override its constants and set everything to 8. Perfect. Make it span across the whole screen. And then first thing I'm going to add is going to be a progress bar, which I'm going to call live. bar. Okay, now let's configure this. It should not show any percent. Max value, we can leave that by default. Let's see how it looks. We probably need to set the custom minimum size. 220 looks good. And then also I would like it to be in the left top corner, so use the horizontal alignment. What else? We would probably like to set a theme for it. And instead of just overriding it here, we can actually create a theme. So let's create new theme. Click on it. Then we need to find the progress bar. So let's find the type here. Where is it? Progress bar. And we can start changing stuff for it. So we're looking at the background. The background can stay as it is, but we're interested in changing the fill. So new stylebox flat, and we're going to find nice red color for that. Okay, perfect. This is correct. And basically right now we can see it in the preview. Need to disable anything else? No. So we have our wonderful progress bar style. And what we can do is we can actually save that theme. So I will call this UI dot theme to app. Let's add a new folder, themes, but there's only gonna be one because we will actually reuse that progress bar. Okay, so we have that. Now it's going to be right time to add the player UI script. Let's get the reference to live bar. And then let's see, what we can do is we can create a function called set live bar max value. Say live bar max value is equal to max value, and also update live bar value live bar value is equal to live. I believe this is it for now. So then in a player, what we can do is, for example, we can export this. So export var player UI is equal to is of type player UI, and we don't have that because we need it here as a class name. Perfect. So this should be done. Great. And now do we have ready? We don't. So now in ready, in player, we can say help system. Player UI set live bar max value health system base health. Yeah, and that's basically it. And we should also connect to, or we don't even have to connect to take damage, because we can just say player UI update live bar value, and we have to update it to be health system, current health. And I believe now if we get attacked by zombie, invite call. Oh, we have to pass the reference, right? Because we exported that. Now it's set. If we get hit by zombie, yeah, we can see that our health is actually dropping. Perfect. Wonderful. So we have that out of the way. So yeah, this was the health system for our player. Next thing is going to be introducing the shooting mechanic so that we can actually damage the zombie. Okay, now it's finally time to allow our player to shoot stuff. So we're going to start by creating a bullet scene. We'll choose area 2D as a base scene, and I will rename this to bullet. We need visual representation, sprite 2D. Let's find the proper asset for that. And we have sprite called bullet PNG. Let's save this in scenes. Let's go to 2D. Let's create a collision shape matching the shape of our sprite. Okay, and when the bullet left the camera area, I would like it to be destroyed. So I will use visible on screen notifier, adjust that, and then let's create a bullet script. I'll just attach script, and I want to create new script in scripts. Perfect. So we need a few things here. We need, of course, the class name. This is pretty much standard. Then we need a speed, and you can adjust this to make the bullet go faster or slower. Then move direction to set, but we'll start with 0. Damage per bullet, or just damage really. And then in process, we can move our bullet by saying global position plus equals move directions, direction times delta times speed, right? And we will, when shooting, will be forced to provide the move direction, but this is good because our player will know the move direction beforehand. Okay, then we need to connect to the signals. So on body entered. Okay, and we can just take a look at our collision setting, and this should exist in a bullet layer and only collide with obstacles and with, where are the enemies? Enemies. This is correct. Okay, so if body is zombie, we can just say body take damage. Other than that, QE3. And in our zombie enemy, just to make sure that we don't forget about this, we can just say here at the bottom, take damage, and for now we'll print it. Okay, cool. Going back here, I also need to hook into the visible on screen modifier signal screen exited. And here I'm just gonna QE3, not redraw, QE3. Perfect. We have that out of the way, and that pretty much sums up our bullet scene. Let's now focus on the shooting mechanic in our player. So first thing I'm going to do is I'm going to add a marker 2D, and I'm going to call this shooting system because our shooting script will be attached to that marker. And I'm going to place this marker just at the tip of our gun, because that's where the bullet should come from, right? So this is where the bullets will be shot from. Okay. Next, script, of course. Let's go to scripts, change this to shooting system. And I don't really know why when you are creating a new script, Godot tends to create it with the Pascal case, but I try to remember always to make it match the case that we have in script. But maybe I'm wrong, because we can go and take a look at GGScript style guide, and maybe here we will be able to find something about the naming of the files. Let's see, file names. Use Snakecase for file names. I do. Yeah. Okay, so I don't know why the engine itself would start with the Pascal case. Okay, moving on. Class name shooting system. Okay, and we'll have a bunch of signals here. Signal shot, signal gun reload with ammo in magazine and ammo left, and also maybe next time, because we'll also add pickups for health and ammo, we'll handle the rest there. So I'm going to export var max ammo, set it to 40, and export var total ammo. I'm going to set this to 40 also. Export var magazine size is equal to 10. Ammo in magazine, I'm going to set it to 10 to magazine. I cannot reference it. Also to 10, or I can be smart and do ammo in magazine at the very start is going to be 0, but then when we do ready, we'll say that it should be 0. Ammo in magazine is equal magazine size. Perfect. One thing I would like to add is to actually make our mouse, because if you take a look at our mouse now, this is just a standard cursor. I would like to change it to be a crosshair. So I can say var crosshair texture is preload crosshair. Oh, sorry, to be more precise, there is a version that I want most, and this is crosshair white export. Okay, and then I can just say input set custom mouse cursor crosshair texture. And then also what we need is a bullet scene so that we can spawn our bullets. And this is preload bullet tscn. Perfect. Okay, so we can now set up our input. If input is action just pressed, shoot, well then shoot. And if input is action just pressed, reload, then reload. And it's as simple as that. We need to write the logic for reload. So if total ammo is less or equal to 0, there's nothing that we can do. Let's see how many bullets we are missing in magazine. This is equal to magazine size minus ammo in magazine. Then let's see how many bullets should we reload into magazine. Reloaded amount is equal to bullet missing in magazine if bullet missing in magazine is less than total ammo, else total ammo, right? Because if your magazine size, let's explain this with paint. If your magazine size is 10 and the amount of bullet that you have left in your inventory is 14, right? Then obviously you should reload this to maximum, meaning if you have like 4 bullets left, then you can take 6 bullets out of it to make it 10 again, because this is our magazine size, and this makes us left with 8 bullets in magazine. All clear. But if you have magazine size of 10 and you have 2 in a magazine and 6 left in the inventory, then you can only reload not the magazine size, right? Or how much do you have left to make your magazine full again, but rather how many you have in your ammo in your inventory still. And the result of this will be also 8. So we have 2 scenarios here. Either we have enough ammo to reload our magazine to full, or we have less than what we need, and our magazine after the reload won't be full, but we'll spend all of our ammo in inventory. So we have the ammo to reload. Then we can say total ammo minus equal reloaded amount, and ammo in magazine plus equals reloaded amount. And yeah, and then what we can say is gun reload emit ammo in magazine and total ammo. And this signal is for us to update our UI. Okay, that's it when it comes to reloading. Now shooting. If ammo in magazine is equal to 0, just return. Always wise to do early returns. Other than that, we need to spawn a bullet. So bullet scene instantiate as bullet, and then we need to set bullet damage, and this is going to be owner damage per bullet, and I allow this to reside in the owner because it will be easier to adjust or test. So here in the player, we can do export var damage per bullet is equal to 5. Okay, and now we will be getting this value here. Perfect. What else? Oh, we have the bullet set. Oh, we need to add this to the tree, and be sure to make sure to add this to the tree, not to a parent, because if we add this to a player, the bullet's gonna move when our player is moving, right? We need to add this to like a scene. A child bullet, and then we can decide what should be the movement direction for our bullet. So move direction is equal to get global mouse position minus global position normalized. Then we can say bullet move direction is equal to move direction, bullet global position is equal to global position, and bullet rotation is equal to move direction angle. And we should also say ammo in magazine minus equals 1, and we need to shot emit with ammo in magazine. Let's see, yeah, that should have taken this argument, ammo in magazine as int. And that should be pretty much it. We should be able to shoot now, unless I forgot about something. And it seems that I did. Let's disable the collision shapes in navigation and paths. Yeah, definitely something is not working. So let's see. We shoot. And that might be because our input map is wrong and the shoot is set to mouse wheel left. Okay, that's definitely not it. I want to have mouse button, left mouse button. Left mouse button. Okay, that looks correct. Let's see now. Oh, I set the debugger here. Now we have, okay, we have a bullet, but it's moving so slow. We definitely need to ramp up the speed. Let's see. Let's go to bullet. Speed is 10. Let's make it 100. Better, but still too slow. I'm thinking 300, maybe even 500. Okay, that seems reasonable. Okay, and then as you can see, if I'm gonna shoot the 10 shots, I'm no longer able to shoot, but if I press R, I can shoot again. Perfect. So to finish this up, actually, in the next section, or maybe actually we can do it in that section. Let's build the UI for our gun. So let's go to UI, and let's start by placing HBox container. Okay, and inside of it, I'm gonna create a VBox container, and I'm gonna create a label. Okay, and I'm going to name this ammo left label. I'm going to name this ammo container. Perfect. Let's see. And this should be stuck to the bottom and to left. And here I can just say we'll display the amount of the ammo left. One thing that I will do is I will go to theme overrides, font sizes, and change the font size to 40. Now, the thing that we need to do is actually use our, let me see, bullet icon to represent how many bullets we still have in the chamber. That's not a problem. We'll do that via code. So let's create new function, set max ammo, which is going to be int, and I will say for I in max ammo, we'll create new texture. We need the reference to the bullet icon. Let's call this bullet texture, and this is going to be texture rect new ammo texture rect texture bullet texture. Then ammo, we need to set the stretch mode, so that's going to be texture stretch keep. That's correct. Ammo texture rect. We also need to set the texture filter, because if you take a look at it, my wonderful artistic skills allowed me to create this as a pixel art, so we need to set the proper nearest filter. So filter nearest, yes. And then ammo container, we need a reference to ammo container, and we can access as unique name. Okay, and if you don't know what access as unique name does, it just allows us to directly access the shortened name of the node instead of going through the whole path in a tree. Because in our case, that would be margin container, HBox container, ammo container without the unique name. And right now it's just more pleasant. So ammo container add child ammo texture rect. Okay, and what should we do in the start of our game is to set the max ammo in our player. So here I can say player UI set max ammo, and we need the reference to the shooting system. So shooting system as shooting system max ammo, and let's see where that works. And this is a little bit too much. Set max ammo. What I'm doing wrong is, oh, that should be not max ammo, but this should be a magazine size, of course. So go to player, magazine size. Now we should have, yeah, okay. Then bullets. Next to set is max ammo left, so we'll go to player UI, and then in player UI we'll write set ammo left, and that's equal ammo left label text is equal to %d ammo left. Okay, that's one thing done. Then we should also handle what should happen if the bullet is shot. What we'll do is we will find the current bullet count, get child count, we say bullet texture rect is equal to ammo container get child bullet count -1 minus bullet number, and we will say bullet texture rect modulate color white, so basically white with the 50% of opacity. Okay, and now we need to go to a player and we need to listen to shooting system shot connect on shot, and on shot, let me see, on shot we will have ammo in magazine here, so we can say player UI bullet shot ammo in magazine. Okay, let's see how this works. Yeah, you can see that they're faded out, right? Okay, so the last thing to do is also handle the reload. So we need to connect to reload. Gun reload. Connect on reload. On reload, we do ammo in magazine, ammo left. And we'll just call player UI gun reloaded, ammo in magazine, and ammo left. And now we can handle it in UI. So gun reloaded with information about the ammo that will be in the magazine after the reload. And remember, you don't always reload to full. And then total ammo left, right? Okay. So again, what you can do is say, take the bullet count, and for, take the bullet count, and for I in ammo in magazine, bullet texture rect is ammo container get child, bullet count minus I, minus 1, minus E. And then bullet texture, we need to modulate it back to the full color. And this can be done by applying color white. Because if your texture, for example, is green and you modulate it with white color, it will still be green because it's like multiplication. And then I can just call set ammo left to total ammo left. And let's see whether our UI updates correctly for that case. So I'm shooting and this isn't working. Okay, so the first thing that I see when I play the game is that we have a 10 here, but what we should have instead in our game is the information about the ammo left. So the UI set ammo left, shooting system, max ammo should be 40. Okay, now I am shooting and I would like to reload and we crash. Let's see why. Of course, this is a stupid typo on my part. That should be bullet texture rect that we want to modulate. Oh, let's see. And reload. And now it updates. So yeah, we have our gun and we can reload it. Perfect. So yeah, that pretty much sums up the shooting. But what we have to do is actually allow our player to destroy zombies. So in the next section, we'll introduce health system for a zombie. Let's finally be able to kill our zombie. So to do that, we need to go to our zombie enemy and we need to introduce a health system for him. So what we can do is we'll simply add new empty node. Let's move it outside of the attack area. Call this health system. And attach a script. And let's find, oh, this is the inherits. No, we need to find the path and point to our health system. And funnily enough, we really don't need to change anything here, right? Maybe we could change base health, but we'll see. Now, the thing that we actually need to change is our UI. So let me think, how can we do this? We could extend our current script, but that's not the way. The better way would be to add the live bar here. So add child, I will search for progress bar. We can find a theme for it and quick load theme. Then we need to rotate it 90 degree, place it like below. Let's see, do not show the percentage. Let's see if we change the value to 20, begin to end, can switch from top to bottom. Cool. Let's see. So do we need to rotate 3? Transform. Let's see. We should just simply change the size to 40 by 10. So just simply go to the transform of the live bar. Okay. Then we apply the UI theme. Let's see. There's also should be something like, no, I don't want it rounded. Then if I bump up the value to, let's say 20, and then from begin to end, now it looks correct. Cool. So then we can just add a simple script to our live bar, and I can call this live bar. So let's go to scripts, or maybe even be more precise and call this zombie live bar. Let's add a class name. And let's get a reference to our help system. And then in ready, I can say max value is equal to health system base health. And let's cast this. Health system damage taken connect on the damage taken value is equal to max value, and then on damage taken current health value is equal to current health. I believe that's it. Also, for our zombie, we should connect to the health system because we need information about when the given zombie died. So here, let's get the reference to health system. And let's connect to it in onReady. So health system died, connect on died. And then on died, we will simply call QE3. Okay, let's see. Oh, I know what is going on. In our bullet, we have take damage in the zombie, but right now we're not doing anything when we are taking damage. So here it's enough for us to just say health system take damage. And let's see. Now we can kill our zombies. Great success. Okay, what else would like to implement? I would like to implement pickups. So the ammo pickup and the health pickup, and that's going to be in the next section. And also zombie being able to drop the pickup when he dies, just like spying some loot when we kill a zombie. So that's what we'll handle in the next section. Okay, let's get those pickups rolling. So if you go to assets, I created two icons like ammo pickup, and that's supposed to be an ammo box, and health pickup, of which I'm really proud because it actually looks like a health pickup. So let's go to scene, new scene, and let's handle ammo pickup first. We'll need area2d, and we will of course need a sprite. Let's drop the ammo pickup here. Let's go to 2D. We will set the texture filter to nearest. So now it's sharp. Let's save this as ammo pickup. Go to scenes. This is fine. And then of course we need collision shape. Make the shape rectangular and make it match the icon. Okay. And then we need a bit of scripting. Let's create the script for ammo pickup. Okay. And the only thing we need is actually callback for the signal. So on body entered. Perfect. Let's check the collision settings. So this should reside in pickup layer, and we should be able to interact with a player. Let's check the player real quick. So this is a player, and he should be able to interact with the pickup and maybe not with himself. Okay. Going back to our coding, all we do is we say body as player on ammo pickup and QE3. Go back to player, and then we can do function on ammo pickup, and we'll just hand it over to our shooting system. So shooting system, and then on ammo pickup, we need to calculate how much ammo should we add in that case, because we don't want the ammo to exceed the maximum amount. So ammo to add is equal to max ammo minus total ammo if total ammo plus magazine size is greater than max ammo, else magazine size. So add up maximally the magazine size, but if the maximal amount of ammo is like 40 and we are at 44 stored in our inventory, then only add 6. And then we can say total ammo to add, and we can say ammo to add oh sorry, not ammo to add, but ammo. Okay, it seems that we need another signal. So signal ammo added total ammo, because we need to update our UI and we can synchronize this with a signal. Ammo that added emit total ammo. Perfect. And then going back to our player. So we need to go to shooting system, ammo added, connect on ammo added. And what we'll do probably in that case is we'll just say player UI set ammo left total ammo, and we can test this really easy. We're going to main and saying instantiates in here ammo pickup, and let's see. Oh, and the problem is we added it to player UI. It should be here, of course. Let's see. I shoot, I reload, and now we have our ammo added. So yeah, in the next section we'll do the same for the health pickup. Okay, let's handle the health pickup. So the way we'll do that is pretty much the same. So area2d, we need a sprite. Let's drop the health pickup. Set the texture to nearest. Change the name to health pickup. Okay, let's add the collision shape. Let's make it match. Okay, and now we can save this as a health pickup. We need to add the script. We will save this in scripts. Get rid of everything. We'll just sort information about the health amount restored, set it to 3 or 4 or 5 as you wish. And we need to connect to body entered. Also, make sure that your health pickup exists in the correct layer. So move it to 7. And then we can say body as player on health pickup health amount restored and Q3. And this is all that we need from here. Let's go to our player. And you can imagine that this is going to be health to restore int, and we can just say health system current health plus equals health to restore, and then we can say player UI, and we need live bar value plus equals health to restore, and that should pretty much be it now that I think of it. Yeah, so we can go to main and we can instantiate scene here, health pickup, place it over here. Let's make sure that we are getting attacked by zombie and we lose some health. Go over the pickup, and I'm not sure, did we restore health? I think we did. Let's try this again. Yeah, we restored a little bit of health. Perfect. So with that done, the next thing I would like to add is zombies dropping our pickups randomly. This is going to be rather simple. All we need to do is go to our zombie enemy, and here when we die, we will create a new function, try drop pickup. Well, let's make it more English, try to drop pickup. And yeah, and also probably we should call deferred I had some issues with that function. So let's defer it to when we actually have the possibility to call it. Try to drop pickup. Okay, and what we need is reference to ammo pickup scene and health pickup scene. So here I can say ammo pickup scene is equal to preload ammo pickup, and then health pickup scene is equal to preload health pickup. And that should be, of course, that is not correct, my friend. We are looking for ammo pickup TSCN. Perfect. So now we need to define a chance to drop the pickup. And I will just say that let's say export group pickups export chance to drop pickup is like half. Then we can say random like current pickup drop chance is equal to randf, and it's gonna return the number from 0 to 1 randomly. You can say if current pickup drop chance is greater than chance to drop the pickup, we will drop the pickup. But then we have to decide what pickup to drop, and we can again do it randomly. So random f, again, can compare this with chance to drop the pickup, right? But we can even split it like let's say ammo to health pickup ratio. I'm also going to set it to half, but maybe we'll drop what's more important. I believe ammo. So I can say if this is lower than ammo to health pickup ratio, we'll spawn the ammo. So ammo pickup is equal to ammo pickup scene instantiate get 3 root add child ammo pickup global position is equal to global position, else health pickup is equal to health pickup scene instantiate get 3 root add child health pickup global position, basically copy and paste. Nice. And now when we die, when we kill a zombie, there should be a chance for him to drop something. Okay, maybe not always, but he dropped some ammo. Cool. Okay. But there's one thing I would like to add to our zombie real quick. So we have a health system, and whenever we take damage, I would like to connect to my state machine, and no matter what you're doing, I would like to, if state name is not equal to Chase, and state name is not equal to attack. So basically, if we're idle or wandering, transition to Chase. So if we shoot a zombie, he will immediately start chasing us. Let's see. Come on, come here. Nice. Okay, that's way, way better. Perfect. So we have that handled. So in the next section, we will actually introduce a goal to our game, and our player will have to find a key on the map and also extract with it. Okay, so far our game had no real goal. So I decided to introduce one. We could just be happy with killing numbers of zombies, but that would be boring and stupid. Instead, my favorite game is Escape from Tarkov, and it's a very hard game to play, but basically what you have to do is to go into load into a map with other players because it's multiplayer, do some objectives located in different places on the map, and then try to survive and extract via specially designated places that you have to come to, often with some additional conditions like paying for it or not having a bag, and then you have to survive in that extraction zone for a few seconds, and then you like finish your run and survived and won. So let's try to introduce this to our game with a very simplified way. So first thing I'm going to do is I'm going to create a key pickup. So let's create another area 2D. Let's then add a sprite. And I try to create something that looks like a key. I hope it's at least recognizable. So set the filter to nearest and also add a collision shape. And this could be rectangle. This is fine. Okay, let's save this as a key pickup. And then I will also add a very simple script. Make sure to set the layer to pickup and mask collision to player. Okay, and then we will connect to, of course, on body entered. Perfect. And then just call body as player. On key pickup and QE3. Okay, they're then going to player on key pickup. We create a variable here at the top, has key, and we will set it to false. and then we'll switch it to true, and we'll update this in UI, player UI. How can we call this? On key pickup. Okay, going back to UI, what we can do is we can add a key icon here. So let's just add texture rect, and let's configure that. So go to inspector, the texture is key, the texture is nearest. Okay, it just looks bad, so let's switch the expand mode to fit width. And let's see, do we need, that's 55 by 55. This is fine by me. And let's click on that eye to hide it at the very start, because at the very start our player doesn't have a key. And then in player UI, I can just get a reference to that. It's called this key icon. And you can see again, this is the ugly long path, but we can just access as unique. And then I can say on key pickup, key icon show. And let's test this by going to main. Let's drop a key here, key pickup. Let's see what happens when we go over the key. Now we can see in our UI that we have our key, but what to do with it? Basically, we'll use it as a trigger for extraction. So let's create those extracts. We will use another Aria2D. And typically in the Tarkov game, it has no visual representation. So if you don't have that knowledge of the game, you actually have to find the extraction. And I thought that's a cool idea. We can use it there. And I was definitely not too lazy to draw any kind of extraction sprite. So let's add a rectangular shape. Let's make it a little bit bigger. And what we will add here, let's call this extract and save this. We'll also need a random timer. And I configured it to be from 2 to 5. Perfect. Let's see. Yeah, we'll need a script here. So let's create one. Go to scripts. Perfect. So we need the reference to a random timer. And we also need a reference to a player. So we'll get one very easy. We need to connect to onBody enter and onBody exited. Yes. Yes, and we need to connect to timeout. Okay. Let's see. Only if the player has a key will we say that player is a body, and we will start our random timer by calling, let's cast this by calling setup. Then on body exited, we will start the random timer. We will call body as player, we'll need few functions there. Hide extract countdown, and we'll set the player to be null. And on a random timer timeout, we'll say also random timer stop and player extract. And we don't have those functions here, but more importantly, in function process, if random timer is not stopped, we'll call player update extract timer with random timer time left. Cool. So all we need to do is write those functions in our player. Okay, so first things first, we need to go to our UI, and we will need to add one thing, and that's the extract countdown label. So in margin container, let's find the label. Let's call this extract counter label. Let's place it at the top, in the middle. Let's see, and let's see how it looks like. 10s. Maybe we can make it a little bit bigger. Let's change the font size to 40. Perfect. Now that we have it, we can use it in our code. So let's start by updating our UI first. So what we have here is we need the reference to that. And then we'll just say hide extract countdown, and this will just call hide. And the second function is update extract timer with a time left. First, we'll check if extract time label is hidden. And if it is, then we'll show it. And then we'll set the label text to proper format. And I would like to present the seconds with only two decimal places. So that's the format for it. And then we provide time left. Cool. And now with those functions here in player UI, we can go back to our player and fill out what we need. So let's see. First thing we need is update extract timer with time left. And we're just passing stuff here to player UI. And then hide extract countdown. Player UI, hide extract the countdown. Okay, and to test this, we need to place our extracts. So let's instantiate scene here. Let's find extract. And we can place one here. And then maybe one. Oh, I even prepared like the openings. I forgot about this. So there is a visual information about extract being there. And then one here. Okay, so the scenario that we have is our player should grab the key and run to extract. Let's see if that works. And I have a key. And I am running here. And oh, we need to to go to player UI, hide that at the start, get rid of that. And maybe, no, that's fine. Okay, to test this faster, I'm gonna go to 2D and I'm gonna move my player right here and I'm gonna find a key. And also I'm gonna move it right next to a player and next to an extract. Okay, and now if the timer runs out, we basically, yeah, we should extract. So let's write that function. And we will just say show win UI and we'll create it right now. So that's going to be very simple UI because I'm not an UI designer. And also designing a really nice, beautiful UI is an art in itself. And it takes a whole lot of time. Okay, let's start by adding center container. And then we'll call this game over container. Next, we'll add a panel. Let's see, and that panel will have a size of 200 by 200. Let's make this span all over so that the panel is centered. Then we'll add VBox container. Also make it span its parent. Add a label, which I will call game over label. And I will add, I will add a button, which I will call, let's see, play again. Say play again button, and this is very minimalistic UI. I'm gonna grab this thing and place it in the middle. Let's see, for example, game over. Okay, that looks good enough. So the first thing that we can handle pretty much immediately is what should happen when we press the button. We'll just say get 3 build current scene. This is the simplest thing that I can do. Then this should be accessible as unique, yes, as unique name. Let's create reference to it. And then we'll create a function. We call this on game over. We'll pass here is game lost. And if is game lost, game over label text you have died, right? And then game over, we'll also need a reference to game over container because it's going to be hidden at the very start. So game over container show, and let's hide this. And by default, then we can say that you have extracted and smiley face. Okay, and then let's see. In player, we'll not go show win UI, but we'll say on game over, and game is not lost. So false. Let's see. And I extract. You have extracted. That's not correct. Extracted. Okay. And probably what we can also do on extract is just call in our player just QE3. So this left us with the one last thing to do for our UI, and this is let's see. This should be in our health system. So health system died connect from died. Very simple function. And we'll just say player UI on game over true because game is lost, and then QE3. Okay, so now let's test whether we can die. Let's grab our player, place him next to a zombie. Come on, attack me. And I have died. Perfect, and we can play again. Cool. So we have the extraction and key mechanics done. In the next section, we should handle the sounds. So in our assets folder in sounds, you will find some sounds that we will use to make our game better. And we will start by adding the sounds of the zombie. So let's go to a zombie enemy and let's add an empty node, call this sounds. And what we'll need is audio stream player 2D, and copy it 3 times, and we'll call this zombie attack sound 1, and maybe now it's better to copy them. Okay, and then we pass as a stream in editor zombie attack 1 for sound 1, zombie attack 2 for sound 2, and zombie attack 3 for sound 3. Perfect. With all of that set up, what we can do is we can go to our state machine and then how do we do it? We'll do this in state machine attack. Right here, I'm gonna get a reference to sounds. And then whenever we attack, so here, when player takes damage, I'll say random stream player is equal to sounds get children pick random, and then just random stream player play, and you will really see how sounds brings a next level to the game. Then also in case we're gonna do pretty much the same, so let's get the reference to sounds, and then whenever we enter the chase state, we'll also play a sound. So again, random stream player equal to zombie to sounds get children pick random stream player play. Okay, Let's see how it works. Kinda cool, kinda great. So we have that handled. Then we have pistol shot and pistol reload sounds. So let's go to a player, and then we can add a thread node. Also do sounds. Add a stream player. Call this shot stream player. Add another one. Call this reload stream player, and then let's get references to those. Let's provide the proper sound. So pistol shot, pistol reload. Okay. And now we just need to play this. So let me show you something. You might think that on shot we should do shot stream player play, but that's not going to work. Why is it not working? Oh, because it's on ammo pickup. Of course, it should be on shot. Sorry, it's very late at night. So bugs do creep in. But actually what we should be doing, because those sounds can overlap one another. So we should check first, again, not here. We should check first if shot stream player playing is false, so that the next sound will only begin if the previous one ended. Actually, maybe in that case, because this is such a short sound, maybe this was actually way better. Cool. Okay. And then reload. Let's see. On reload. So here we can just say a reload stream player play. Nice. Perfect. So with that done, one more sound that I wanted to add is a pickup sound. And this has to be done a little bit different, because maybe I'll try to explain it with paint. We have a pickup, like a health pickup. And when the player comes in, what we do is we call QE3, right? But if we add stream player to the pickup and we try to play it, and then immediately after that on pickup we will also call the QE3, the whole node will be deleted with our audio player inside of it also gone, so the sound will not play. So in case when you would like to play a sound, when some node is deleted, the audio player has to exist outside of the node, or the node can be deleted only after the sound is played, because otherwise you won't hear a sound. That's why we will go to main and we'll do a little nice trick. Here we'll add our player, and I'll call this pickup stream player. I will provide a pickup sound, which is very nice, by the way. And I will add it to a group. And I will call this pickup player. And I will add pickup stream player to it. Perfect. And then in our pickups, I can just say get first node in a group, pickup player, and call up play on it. Okay, and then I can move this to all pickups. So health pickup and key pickup. Okay, let's see where that works. So I have a key nearby and other pickups too. Let's try this. Nice. Perfect. And these are all sounds that we have. We could expand upon it indefinitely. For example, maybe if you have a gunshot, then the zombies nearby in some kind of radius go into investigate state and try to find out where the shot came from. But as you can tell, you can expand upon that game more and more. There's one more cool feature that I would like to add, because right now we can see everything in our game, but in reality you only see, like in FPS games, what's in front of you. So I would like to limit the view of my player to some kind of cone, and there's a cool way to do it, and we will do it in the next section. Okay, so I would like to add a cone of view for our game. So our player should not be able to see like everything around it, but I would rather have his vision limited to maybe a circle very close nearby and then a cone in front of him. And that might be a little bit complicated, but I think we might make it work rather easily. We'll not use stuff like shaders or occlusion. We'll try to keep it as simple as possible. So let's start by adding a canvas modulate node to our game, and let's change it to something darker, and that will imitate that our player doesn't have a vision there. Okay, then what we need actually is, let's collapse that. We'll need to go to a player, and we will need to add a node which is point light 2D. So point light 2D, and we will need to provide it with a texture. And I created one, and it's called how is it called? Visibility mask. It should be there. Oh, I didn't add it. Okay, let's add it. And this should be this one. Oh, let me add it. Oh, where is it? Visibility mask. Here it is. Okay, and that should add a new file called, oh, it's in the sounds for some reason. Let's move it to assets. Okay. Now it's in the wrong place too. In assets, please. Yes, visibility mask 1. Let's drag and drop it here. And now let's set the texture scale to 2. And we need to configure it a little bit. Okay. So the transform position, let's see, it's -9. Scale is set to 1. The texture scale is set to 2. Energy can be set to 1. We will change the blend mode, this is very important, to mix. And then we need to set the visibility. And I will set it to light mask 2 and visibility layer 1. Okay. And as you can see, we already have that effect of the cone. The problem now is that I would like to have zombies and the keycaps obstructed by it. Okay, so if it's not in the light, it shouldn't be visible. So let's go to zombie enemy and let's go to a sprite, and we'll need a new material. And it's going to be new canvas material. And let's see, we will need to change the light mode to light only. Okay. And we will also need to, maybe that's it. Let me think. It's not visible, and now it's visible. That's what I wanted. Perfect. Okay, so other things I would like to change is, of course, the live bar to use the same material, so we can save it. Save as, let's create new folder, keep everything nice and tidy, materials, and this should be light only dot. You can see all the names here that you can give to your file extension, and this is supposed to be material. Okay, the same we can apply to the live bar because it also shouldn't be visible. Then I think we can hide the site label as we do not need it for debugging anymore. And go back to pickup and do the same. Meaning choose the material from quick load, the key pickup, and the health pickup. Let's see whether that works. So I don't see my zombie. Only now it's a scary shooter horror, right? But I can see that I'm still able to see my pickups, and this is because I added the material in the wrong place. So let's clear this. It should be on sprite, obviously. So change it here, clear it from here, and change it to be applied to sprite. And also here, clear, and apply this to quick load and apply to sprite material naturally. Okay, let's see how this presents itself. Okay, and now only in the light I am able to see my pickups. And that's gonna be it for the game. What you can do for that game is to actually spawn more zombie enemies. Where is he? And place them all over the map, and maybe place the key somewhere else. And to make it full into a game, well, this is a game actually, but there's still more to add. For example, We could add different weapons. We could add different enemies, because zombie enemy is the simplest possible enemy AI, but I can see us adding enemy that shoots back at us. We could add different keys. We could add doors and interaction with the doors for AI and for the player. We could add more interactable elements. We could add inventory system where you don't use the pickups immediately, but rather store them in some kind of inventory system. So this is something that we can really expand upon, and I can add more features. Maybe I will revisit this in the future, but for now I'm calling quits and I'm calling this done. So yeah, it took a lot of time and effort to prepare. I would really appreciate if you could give me a like, comment, and maybe subscribe, because it really helps the channel grow. I already have plans for the next tutorials that I will be doing. I will try to make because I love Halloween, I will try to make a special episode for Halloween. So thank you for that, and I will see you in the next one. Goodbye.